Good afternoon, all. When I'm present here, surveying is a subject of practice rather than theoretical. In surveying, every concept from the book comes in use only if we use it practically. For this session, we got a very great personality whose practical experience is like ocean. Mr. R.N. Deshpande, sir. Good afternoon, sir. He is
Good
a
afternoon.
professional. Good afternoon. He is a professional surveyor and entrepreneur. He is a technical senior associate in Oak Deshpande Surveyor and Contractor. He is an expert in all survey-related work, and his every job is an example of well-practiced survey. I request Mr. R.N. Deshpande, sir, to start the session. Over to you, sir.
Thank you very much, and good afternoon, everybody. My name is R.M. Raghavendra Deshpande. I am not a teacher by profession, so what I would be doing today, and I would like to share some of my works, and then how the works are conducted, why these surveys are conducted, how they are conducted, and what is the output we actually get from the survey. As you all aware of, and in the previous session you must have witnessed the introduction to the total station. You must have seen the instrument itself and how to use it, and the parts and every other things, the parts and parts of the machine and the accessories, everything you must have seen. Now I would like to start a presentation in which we would like to see the type of survey, rather not type of survey, the utilities of survey what we are conducting over a period of time. We have just categorized all these survey into a few headings, and I would like to explain it one by one. Once the explanation and the drawings, the explanation is over, I would like to share some of my works, the drawings which I have got with me on the laptop, and then we would end it with the any question answer session. Let me share the presentation now.
आजार होऊ न देणं किंवा तो झालाच तर विकोपाला जाऊ न देणं यासाठी शरीरामध्ये अहोरात्र काम करणार.
Okay, now as you can see, the subject is a process of surveying with total station. The process of surveying with total station, if you see that, I will just go through the total station. This is electronic total station, what you must have seen in the previous session. Now I would like to go on with the type of survey what we are conducting. Now, whenever any survey is done for any piece of land, then survey means generally it is interpreted as a topographic survey. So for any particular piece of land, whenever you want to do a project on that land, we have to do a topographic survey along with the features and the dimensions and geometry of the plot. Now this is normally done for before planning of the project. This will give us the ground data before starting of the project. Now it includes all the topographical features such as burns, streams, valleys, trees, and man-made features like electric pole, light poles,
Excuse me, sir.
structures.
Can you share the PPT?
Oh, sorry. Okay, I'll just go through it once again. Before starting of any project, as you know that the surveying is very important. Nowadays, it is more important because any erroneous survey would directly result in an increase in the cost and the time of the project. Now, the very basic survey, the topographic survey, what everybody understands as a contour survey or topographic survey, this is normally done before starting of any work, and this is very much essential for planning of the project. This gives us all the ground data before starting of the project, which includes topographical features such as burns, streams, valleys, trees, electric poles, light poles, etc., and so on, even the structure footprint as well. And along with that, we collect the spot levels randomly. Nowadays we can't really mark the grid on the ground, so we collect the levels randomly, and we ensure that the distance between any two adjacent levels is about 5 meters or so. But this 5 meter by 5 meter grid and the contours with the appropriate level. Now this 5 meter by 5 meter grid essentially helps us in quantification of earthwork for gradation and everything. The basic data what we follow regarding the design is always the contours. But when we want to have it in numbers, then this 5 meter by 5 meter grid is very essential at that point of time. Now, when we say that we are going with the 5 meter by 5 meter grid, that doesn't necessarily mean that we have to take level set every 5 meter only and miss the in between data, in between the features. So, 5 meter by 5 meter grid is a sort of a convenience which is represented on drawing. When it comes to collecting the features on the side, like the nalas or streams or valleys, then this 5 meter grid becomes redundant. You have to take all those levels at those points so that the features are properly and reasonably well represented on the drawing. Now, this 5 meter by 5 meter grid and the contour interval is normally decided on site depending upon the nature of the topography, and it does not. I mean, there is no other specific rule for that. We have to understand how the topography is well represented. So it starts from say 0.5 meter to 1 meter. Normally, whenever we represent a drawing, contour drawing in AutoCAD, we normally show it as a 1 meter contour and a 5 meter contour. So that when that 1 meter contour or 5 meter contour, you tend to understand the level difference easily, and it is highlighted on the drawing. Now, each and every consultant, right, from the architect, structural consultant, landscape architect, services consultant, electrical consultant, will be benefited by this survey, and this data is very much useful for them for any kind of planning, estimation, and further execution as well. Now we'll move on to the other part. Next part. Now, when this contour survey goes to the architect, and then architect and the subsequent consultants, then they prepare a plan based on this contour survey. Now, whenever this plan is prepared, we need to check whether it really fits on the ground. It is mostly for the convenience of the engineer on site. We can visually confirm all this, that okay, this is fitting well within the requirement setbacks and all, and the architects and the required consultants can come and check those things. So we call it as a block plan set out. So after the planning is done based on the topographic survey, the layout is prepared and the same is ready for marking on ground. Now at this stage, we normally recommend to mark the block plan only on the ground, just to get the confirmation about the layout fitting, and also to start infrastructure work, because then even in any site you want to start any site, you need to mobilize, you need to build some roads, you need to put up the labor camps and RMC plants and so on and so forth. So for that, if the layout is marked, then you can essentially see and visually see the areas which can be put to use right from the beginning, so that it doesn't disturb the entire layout. I mean, it should not so happen that whenever you are starting any work, then you are putting some steel yard or the cement go down or the RMC plant, and suddenly you realize that no, the project has to start from the same site. So to avoid that, we need to mark all this layout on the ground. This is very essential at the initial stage to understand how it is being placed on the ground, and then everybody is visually and conceptually clear that which area is going to be developed in the initial stages, which is going to develop in the later stages, and accordingly, then they will put up their what you can say labor colony, RMC plant, site offices, or even the nowadays a sample flat if it is a residential work. Even at this stage of work, we can even construct the grid pillars depending upon the size of project, maybe 25 meter by 25 meter grid or 50 meter by 50 meter grid. This helps us in because whenever a person goes on site and if he doesn't have a surveying agency along with him, then with the help of the grid, he can determine the area and he can see in which area he is, and he can start any kind of work based on that 25 meter by 25 meter grid or 50 by 50 meter grid. And this helps us in dividing the entire plot area into small sectors and becomes easier to locate anything broadly without help of a surveyor. The essential part of this that the dependency on the surveying agency is reduced here, so that the site engineer itself can take care of the day-to-day work, and you don't have to call the surveying agency all the time for even any small works. Nowadays, everybody's equipped with the total station, even if it's a client, a contractor, or even the main client, or even the contractor. But still, this helps in understanding the area, and as we call it, working from whole to part, the very principle is also established when we do this kind of division of the plot. So once, so we have now so far now seen that we have done the topographic survey and then the block plan set out based on the design and I mean the layout prepared by the architect. Now the next stage is individual building set out. Now once this is ready, the labor and everything has been mobilized on ground, and once these things are mobilized, then the actual work needs to start. Nowadays, if you want to start it by excavation and if there is a basement and all, the earlier layout, what we have done, the block layout, this is good enough to start the work. So we can start with the excavation, go up to the required level, basement level, and then the individual building set out seeps in. Now, after the earlier set out is complete, we can start the execution of any of the building as per priority defined. PCC. Now this process normally, whenever set out, we try to see that our visits to the sites are minimized so that we can optimize the work, we can give maximum out. So happens that once you go on the site, then the excavation is done. If it is an individual footing, then we have to then we normally mark the PCC corners first after inside the block plan set out. And once these things are marked, then the excavation goes on. Once the excavation is done, then we don't need very much accuracy for the PCC. So the PCC has been laid there. And once the PCC is done, now we have to start marking of footings or columns. So columns and footings goes hand in hand. It's not that we mark footings separately and columns separately. So the footing and column are marked based on the drawings available with us, the centerline plan and the block plan combined. And then when we mark these footings on the PCC, normally they are marked as a center line of the center line beyond the box of footing. So the carpenter prepares a box of footing, the fitter prepares the base mesh and the column reinforcement. It is put on the site, and when we want to finalize the footing block, then we normally mark it the center line, which is beyond the footing block, so that the footing box can be aligned with that center line, and so the column and footing are fixed. Once you fix the footing block, we normally mark 5 points for these kind of setup. The 4 points are plus in the plus manner beyond the footing, and the one is the column center. So they aligned all the footings and columns, and they fixed the box there. Then along with that, at times when the footings are the footings individual footings are there, we even try to build pillars on the center line. So these pillars are normally built beyond 4 meter or 5 meter beyond the footing line, so that they remain there for a longer time and they are not disturbed. So, and on those pillars, brick pillars or concrete pillars, depending upon the strata, we can put the center line points at a particular distance, say around normally a rounded figure. And now from that, then they put up then they fix a line dori, and with that on both the sides they can again fix it without calling the surveyor on site. So likewise also there these two are the options which are being followed for work on site. It depends upon the availability of the engineers, the crew on the site, and the what we can say the competence of the people on the site as well. Now, once the footings are cast, we can give column starter points on footing as well. Now, this sequence ensure absolute accuracy in structural work to start with. So, whenever a footing is cast, then the column starter is very essential, because then instead of casting the whole column for the first lift, say about 1.2 to 1.5 meters, once you get more accuracy for about a 6-inch column starter when we fix on the ground. Again, for column starter, the same principle is followed. The points are marked in a fashion that we take it outside the column about a meter or so that the line is filled. They can line dori put a line dori on x and y direction, and then they can fix the column starter. Once these column starters are checked, then it is very easy for to take up the columns further, and then take up for the whole. Then we don't need to come into the picture till the columns and the slabs are cast for the full height, and then the slab is cast, because then the column has to go with the along in accordance with the plumb line and so further. After that, once this individual building set out is done at the basement level, at the footing level, Now this will, we are just talking about the columns here, but the same thing will go for the retaining wall as well. If there is a basement and we have a retaining wall, then we normally try to uh, mark the inside face of the retaining wall. Now, why inside face? Because normally sometimes the walls are tapered from the outside, although sometimes the thickness is not been fixed at time. So to start with, we can fix that, fix the inside face of the retaining wall so that the rest of the work can start. The PCC, footing for the retaining wall, and even the reinforcement of the retaining wall. And the thickness and those things can be taken care within the stipulated time before you actually do the concreting of that retaining wall. And once these things are done, normally in many of the cases which we have seen, our work as a surveying agency will stop when we do the column starters above the footing. From there on, the people can do their job based on the plumb line, and they can even take those columns for all of the rest of the floors. At times they require to do the column setting out on every floor. Now, this every floor, when we say on every floor, once the slab is cast, a stage comes for erecting columns above the slab. Again, the procedure and the principle is same, because then we have to. Otherwise, when if you are not there in the picture, then they have to do it with the plumb bob for verticality, that the position of column on every floor can be maintained. When we have to do that, when we do that, when we normally fix the control points in such a way that the control points for all the floor remain fixed, so that whenever the slab is cast, we can say, shift our control from the base ground floor to the first, second, third, fourth, fifth floor. Likewise, we have to take the station far away from the main building so that we maintain a visibility, and then we are able to see the prism, the what can mini prism, and the point. And once we shift the station on the upper floors, then the same procedure follows, and then we do it for the column starters. Once the column starters are done, again they can take up the columns for the rest of the floor. This sometimes helps in reducing the cost of plaster, what we have observed over the period of time, because maintaining the verticality over a number of floors is definitely a challenging task, and it really requires some assistance to maintain those verticality, because then they also need to ensure it is not just the plaster cost of plaster, they also need to ensure that the columns are not going eccentric, and that happens many a times on the site. Once this building is now the building is in place and its construction has started. Likewise, the rest of the buildings also can start, and then we move on to the setting out of infrastructure. Now, in this infrastructure, we need to mark the service line, the landscaping at various stages of works, even the road lines, footpaths, the dividers. All these things can be marked, and these needs to be marked before the excavation and after the excavation as well. Now, this setting out normally for the infrastructure development is repeated many a times depending upon the sequence of the work and at what stage that we are doing that setting out. So before excavation, after excavation, then if there is a road, then we need to grade that road to a particular level. Before that, we need to mark it on the ground. So once it is marked, then the gradation is done. Once the gradation is done, then if the required, depending on the required excavation and all, at times the points are lost because of the gradation work. Then again, it needs to be fixed, and the further stages of work can then go on. Nowadays, if you see, now there are many high-rise buildings are coming up, and they have extensive podiums. I mean, even the buildings are apart, with some distance in between them. The podium is connected. Now, podium is another ground level created above the natural ground level. So many times the podium contains very many activities such as clubhouse, the landscaping, even the jogging track, then the tennis court or basketball courts, and likewise. Even some sit outs along with the landscape, as they call it, landscape, hardscape, softscape. So the entire whatever we used to mark on the ground, the entire thing has been shifted to the podium. So again, the podium is again a restricted area, and you can see they are not geometrically always in right angles or some angles. They have some curvilinear shapes, and at times very odd shapes which are difficult to mark on the ground manually. So at this junction, the total section can step in and do these markings. As you are well aware that with the help of the total station, what you must have seen in the earlier session is that it contains the electronic theodolite, data processor, and the data storage device also, and it works on x y z coordinate principles. So every point has an independent identity. So whenever we are doing this setting out, I will share a few drawings with you for the setting out also, so that you can understand how the coordinates are worked out and how they are represented on the ground. So with this x y z, you can work out the coordinates at whatever interval you require, and the same points can be marked on the ground as well. So that is how we go for setting out of this infrastructure. Now, as a part of survey, as I told you earlier, that it is a utility sort of a thing nowadays. So, when we look beyond the normals or contemporary surveys, that was, you can say, earlier used to be the plain table survey, which we now call as detailed layout survey. When we say detailed layout survey, it means that all the layout, whatever is there on the ground, all the layout has been picked up and a new drawing has been prepared, which nowadays we can call them as built drawings. Now why these as built drawings are required? If the site is very big and it goes on for say about 4 5 6 years, or even a 1 year or 2 year, then during the course of the construction there are many changes which takes place in the drawings, and they're not necessarily being reflected as a final drawing or a working drawing which comes from the architects or the service engineers. So the as-built drawing basically emphasizes that it's a data drawing for all the further working. Then there are number of agencies which starts working once the project is complete. Housekeeping is one of them. Service line maintenance people are there. Then even the storm water cleaning or the drainage sewage chambers and lines, they have to be maintained. So if you know the exact layout of these things, then it helps a lot for people who are working to do this kind of maintenance work, and it definitely helps for all further future works. Also, it gives you a sort of a, you can say, a BOQ for any expansion work. Now, if the roads are there, if you see that any layout is complete and it has been occupied, started working, and so after 5 years or 6 years, you need to maintain the roads or do another layer on the road or do the concrete road, want to convert it to concrete roads, then you can very easily get the road area from these drawings, which is there. So we call it as an as-built drawing. So what we are seeing here is the data which can be used at different levels of work and for different purposes as well. You have to have an eye to see that, and you make utilize that data at a later stage also. Now, apart from this technical data, which is required for, you can say, estimation and planning and execution purpose, a very important task nowadays, or even right from the beginning, is there as the boundary finalization, what we call it. So normally, when we go to a survey of any plot or any land, we normally collect the boundary which has been shown by client to us. Now these boundaries, or as they call it, they have been using that boundaries over years. We call it as vahivat in our language, Marathi. That, I mean, they are used to use, they are used with that boundary, and it does not necessarily match with the boundary of the record which the government surveyors are having. So whenever we go to any,
सर आवाज येत नाहीये तुमचा.
Okay, sorry for the break. As we are talking about the boundary finalization in coordination with the government documents. As you are aware that our for any land there are two documents which defines that land. One is a 7 by 12 extract, which shows how much area that land is having, that piece of land I mean, and the other is the government demarcation itself, which shows the shape and size of the plot. Unfortunately, the demarcation doesn't give you the area, and the 7 by 12 extra doesn't give the dimensions of the plot. So now how to go about it? So whenever we do this survey, as I told you earlier, we collect the boundary as shown by the client, and that boundary he's been used with that boundary for a lot of time, long time. We call it in Marathi as vahivat. So he's aware of that boundary since his fathers, forefathers, and so on. So that boundary is with him all the time. The boundaries with them all the time. So then what we normally do when we go to the site, we collect the survey boundary as shown by the client. And once that boundary is there, once the boundary is complete, I mean, we prepare the drawing, and the survey is complete, we prepare the drawing, we scan and digitize the government demarcation that has been provided to us. Normally, we need to have these demarcations to the scale of at least 1 to 500 or 1 to 1000, so that the accuracy is maintained and you get more accuracy as compared to 1 to 5000 or so on, which are normally available in the gut book. Then once we superimpose these two drawings, we know the correlation between the existing boundary, that is the physical boundary, and based on this overlapping, then we can finalize this boundary. I mean, we can finalize the boundary, and if required, we can go back to the site again and do the setting out of the boundary. Normally, even if we do this thing, the government survey is inevitable. You cannot escape the government survey. But at that time, at least you know how your land stands and what is the difference between the physical boundary and the government record. So that helps us, and then the what we can say, the variation is very minimum, and the survey by the government surveyor also happens it very easily. Now we can use a survey drawing and government drawings to arrive at common boundary, which can be used for all further works. So apart from whatever surveyor we have already discussed earlier, the topographical survey and the other applications, at the same times the boundary also needs to be finalized. So the setting out work, what we have been discussing, in that setting out work, we also has an aspect of marking and setting out the boundary as well, so that the area is secured, and whenever we measure the setbacks, the actual boundary as per the government record is there standing on the ground, so that there is no discrepancy. Otherwise, many a times so happen that if you don't finalize the boundary, at a later stage you realize that you're not getting the required setback, and then there is a problem with the location of the building and so on. So this is how the process. It's not actually the process of surveying, but how we go on. I mean, how the survey is being useful for any site, right from the very beginning. When a client or a person purchases a plot, or even before that, if you want to verify the before purchasing, he also can do that, and till the end of the that project, and even after the project also, you can do that survey, and we call it as a as built drawing. Now as you have seen that the survey what normally we do, I mean the contemporary survey, as we call it, topographical survey and detailed layout survey. Apart from that, we have been doing setting out of tiling patterns, basketball courts, tennis courts, odd shapes, water bodies, and even details from interior designer, etc. And these are from time to time, depending of the stage of the construction, at then the excavation from the people. Apart from that, nowadays, if you need to measure
हॅलो सर, आवाज येत नाहीये.
ओके, म्यूट होतो.
नाही सर, आवाज येत नाहीये अजून.
आता येत आहे?
येस सर.
ओके. हे दिसतंय का? Other applications, can you see the screen?
येस सर, येस सर.
Okay.
इट्स विजिबल.
What we're talking about, the carpet area measurements or the floor plate measurement as they call it. Now at times we need to check when any IT company or a big company wants to lease premises, then if they want to check whether there is any deviation from the available plans. So the carpet area measurement happens, or even the floor plate measurement happens, and then you get the physical areas for that particular floor or for that particular works are increased. Now, if you say whether it is a surveyor's job, conventionally no, it's not a surveyor's job. But nowadays the floor plates are big, even to the tune of say 10,000 square meters or like that, and measurement by tape or measurement by any other method is not very what you can say fruitful. So total session is again used for these kind of works. Now, as we call it, carpet area measurement of commercial buildings for to know.
सर, आवाज येत नाहीये सर.
So this verification is very much important. So this is one kind of you can say another utility for using total station, practically purpose. Then checking the verticality of the building. Now when we say checking the verticality of the building, now it happens for different levels actually. We have come across few sites where they want to check whether the columns are being constructed properly. So again, as the same procedure what we use for setting out, now this is a reverse one. So we don't have to set out the columns on every slab, but we have to collect the existing columns on every floor likewise. So again, the methodology remains same for putting up control points on every floor. And you have two at least base stations which are far apart and at a distance from the building, and then you have to shift the stations on every floor very easily, and then on every floor you go and collecting every corner of the columns, and then the drawing is prepared. Then when we do this, then we are sure that all the floors are on the same basis. So whenever you put the floor on the other floor, the drawings, you can put it on say to the base point of 0 comma 0 or so, and then they are exactly superimposed on each other, and you can find out the variation. Now this variation, if you can't see in the AutoCAD, then you have coordinates of the 4 points. If you can take those coordinates and put it in the Excel, then with the help of this Excel, you can work out the difference between say first floor and second floor, or if you have collected the data for say first 8 floors, then first floor and 8 floors, and or even between any two subsequent floors likewise. So this is one aspect of checking verticality of the building from structural point of view. Now there is another aspect also. Nowadays, all these buildings, they come with some kind of cladding, the alcomat or the glass, and all that cladding requires some kind of framework which is behind those cladding. Now, when we do this cladding, you need to be sure that the beam faces on which you are putting up the frames, they are exactly in the plumb line. So again, the surveyor job is there, and then you can collect the profile of the beams.
सर, आवाज आता गेला परत.
Okay. Okay. So this what we are discussing, the cladding. Yes, cladding. Then you have to the profile of every level, and again the same thing. They are on the same basis, so you can take that profile in AutoCAD and see the difference between the top floor to bottom floor. Now, why this is required? So, whatever the framework behind that cladding has been designed, at times you may have to put some what you can say some plates in between to counter that difference. So there also you can use total station to for this cladding purposes. Now taking levels, as we're all aware that excavation and earthwork, you definitely need a total station. So taking levels at different stages of excavation to determine the earthwork volume.
ते आवाज नाही. नाही सर.
आता
नाही येतो सर.
So as a for the earthwork, we are not qualified. I mean, the surveyor on the site is not qualified to understand the difference of strata. But as and when you are called on site to take a level, we can definitely take those levels, and the quantity can be worked out. Earthwork quantity can be worked out for any strata. So likewise, the total station can be used on site almost on a daily basis. As we used to use level, auto level, or dumpy level, or tilting level before this, the total station has replaced that, and it is very much useful to take all these things. You all know that taking levels for preparing L section, cross section, for roads, water lines, drainage lines, all these things are definitely there. So these are a few of the applications, and now I would also like to. So these are few of our projects. Now, as we're discussing about all these points, now why total station is different, or why total station is more utilized or more useful than the other instruments. The best part of the auto total station use is this compatibility or interface with the AutoCAD. So as you know that there is a microprocessor which processes the data collected, and there is a storage device. So whatever the storage has been, whatever the device we are storing the data, that data can be downloaded into the computer, which can later take form of a drawing in AutoCAD. Now, why the AutoCAD drawing also you can otherwise also prepare, but you don't have to draft the drawing. Otherwise, for if you go with the combination of say plane table and dumpy level, then the accuracy is not so much. Again, the tachymetry, same thing happens if you want to do it with the theodolite. So apart from that, we realized on येतो आता हा okay. So the best part of the total station is that its interface or compatibility with the AutoCAD. So as you know, that however you can say you have collected the data, unless it is properly represented on the drawing, it has no meaning. And even that drawing has to be like that for a long period of time, and then that drawing can be utilized at different stages of the work, so that this is, you can say, sort of a master data, and even the storage and facilitating that data becomes very easier with total station, which otherwise you have to maintain this hard copies of the drawing, or you can say the plain table sheets how you have worked out, and likewise. So this is how we can say the use of the total station has been increasing on a daily basis in the construction industry, or otherwise for other purposes also. And then there is no stopping for utilization of total station. We have once used total station to understand the quantity of a coal which has been deposited on the in the harbor, and it was wet because of the monsoon, and most of the coal was wet, and they wanted to estimate the quantity of dry coal, or how much coal has been damaged. So we have taken the levels with the grid of say 1 meter by 1 meter, and prepared almost an 800 pages Excel sheet to work out those quantities. So these kind of applications are always there when you are looking, when you are using total station. I mean, whatever you can say you can do it with the total station. You can practically do it. There is no stopping from using total station in any kind of circumstances, even on site or otherwise also. We have been fixing, if you are aware, that in Pune, the Ganeshotsav is a big phenomenon. So Dagudushet Halwai Ganpati, if you are aware, if you have heard, it has a big pandal, and this pandal is in the right in the heart of the city. But the alignment of that pandal was such that you cannot see that the Ganesh idol from a long distance. I mean, almost two junctions, junctions before the pandal. So we have surveyed that area and then surveyed up right up to the two junctions and fixed the alignment of the pendulum in such a way that even if the person is there about say 500 meters, you can very easily at least see that the Ganesh idol is there. I mean, he may not be able to see it clearly. So I mean, these kind of applications are always there. So there is no dearth of the applications. Nowadays also, when I share drawing, I will share with you now. This presentation is almost over, so I will share a few drawings with you, which shows these kind of details which are taken as a part of the survey. I'll just switch over to this AutoCAD drawings. Okay, now on your screen is the drawing of a market yard in Pune. Now this area is almost about 180 acres right in the heart of the city. This is the market yard for selling of vegetables, flowers, and fruits also. So the purpose of this survey was to have a record drawing for the entire area, and also the area of say each of the what we call is the shops, because they want to fix the rent, they want to know how much number of shops is there, if they are in good shape or not, and likewise. So you can see that now this survey includes the details. Why I have shown you this drawing, the details of the data what we collect on the drawing. Now you can see this is the footpath line. Again, is the footpath line. So in between those two footpath is the road. This is the divider. These are the light poles. These are the electric poles, the trees, and this road goes on, and they have the plot here. Their plot starts from here, and you can see taken, and everything is named and numbered. So these kind of surveys are essential when you want to have a record, have an expansion. They can see that these are the vacant areas and where they can go on for the expansion. Now they can see that area. Yes, they can definitely see that area, but they don't have the geometry of the plot. Which way, when you do the survey, you get that geometry of the plot, and then you can get those details and plan accordingly. So these kind of surveys are conducted for any developed plot, where what we call it as detailed layout. As you are aware that whenever you collect the data, okay. So whenever any kind of development is required or assessment of existing data is required, you need to have these kind of drawings. Now, as you know, this drawing is not just a drawing; it's a technical document. So, whenever we say we are referring a drawing or civil drawing, it is always a technical document. So, these kind of documents we are preparing in the survey. Again, I will share with you one more drawing of this as-built facility. Now this facility is the Infosys facility, phase 2 at Hinjewadi. You can see the details. Now these are all. One more thing, when we do these drawings, then you lines and it shows the layer as Pebbles bed. So this drawing doesn't give you anything unless you have the proper lesion and proper layers for that. Now the lesion, we cannot show everything in the lesion, but then we can definitely put these things on different layers. So these are all structures, then the landscapes, the lawns, the plantation, and likewise. So all these things that we have mentioned, and this is the footprint of the structure. Now this footprint of the structure always comes with the floor level. Then these in between are the roads. As I told you earlier, now if they want to change the road or want to repair the road or any part of the road, they will always get the quantity from this AutoCAD drawing. They don't have to go there again and measure that. Even there is no then discrepancy after later on with the contractor's bills and what you can say the BOQ you have prepared. It will absolutely match with each other, and then you can have the proper budget for these kind of works. Then this is a very basic initial stage drawing, topographic survey drawing. Now all these drawings, when we say, I'm just showing you everything from the drawing what we are collecting here. You can see this is a 5 meter by 5 meter grid showing all the levels of every four corners of the grid, and then the contours. Now we normally switch off these layers. I'm just turn off these layers so that you understand the exactly nature of the ground. Now you can see here a very defined line. This, as you can see, is the manhole which normally follows the course of the nala. You can see here this is the line which clearly represents the nala. Since it is not very precise and natural, it doesn't have a specific dimensions. At times, at places it just expands, and at places it is very narrow. These are the developed plots. Now this is a plot which MIDC has earlier developed. So it shows the network of these roads and then the areas in between, and it also shows the adjoining road, because whenever you want to enter into any of the plot, you also need to have the access level from where you want to enter into the plot. So likewise these details are there on the drawings. Then the legend which is there, which gives you what are the things represented by a symbol on the drawing, and likewise. No. This is the very essential, very initial drawing on which now the development will take place. Now, when we give these kind of drawings, they understand whether they want to keep the existing network or whether they want to change the network and go for the entire new layout. So this data helps them in determining these things as well. So decision making also is a part of good survey drawing, which helps them in taking decisions on the existing. Ata? Okay, okay, okay. Now you can see this is about 170 acres, and these lines are the nala on the ground, and the retaining walls they have already done some kind of gradation work here, and the retaining wall, these are the retaining walls, or you can see in the cyan color. And as you can see from the contours as well, these are the undeveloped plot of the land. So here again you can see these kind of details which are required. Then the benchmark is taken at a place on the retaining wall which will remain there for a longer time, even if they want to do any kind of development there. Again the legend is there, and this is how the survey drawings we are preparing based on the data we are collecting and sending to the client. Now, apart from these drawings, I'd also like to share a few drawings with you. Now, as I told you earlier, nowadays, the survey has been done for different purposes. Now, this is a survey for a IT park in the Hinjawadi area. we have done the survey for this tree which has been planted by them over the period of time, and you can see there is no boundaries here because we have not been asked to take the boundaries. We have taken the structures which can then be superimposed on the entire layout. Now, as you can see, these structures will help for these structures will work as a base point for lapping on the layout. These are all trees. These are all trees which have been numbered. The number have been put on the trees as well. Now, this is sort of an environmental audit. So what they want to know from these things, from these drawings, that when this drawing is prepared, you need to submit to the environmental department or the subsequent authorities. They want to check how many trees you have planted and how they have been there. Now we have taken, unfortunately, I don't have the table at the moment, but all these things have been put into the table. Now that table India shows the girth of the perimeter of the tree bole or the trunk, what we call it, and then approximate height of the tree and the name of the tree. So again, now this is again a tree census, but with the position of trees, how they are placed over the entire period or the entire plot. So this is a new type of requirement which has come up in recent times, and this has been extensively being done by a number of agencies, number of what you can say, number of companies. Okay. Now, I'll just now I'll also share with you again. This is one more tree detail drawing. Now you can see this. This is the drawing again numbered, and if you see, say if you want to say 187 number, then the details of 187 number are here. Now what this number shows, this is the approximate height of the tree is 6 meters, and the perimeter of the bole is 0.19 meters, that is 20 centimeters. Now, when you want to take a decision whether this tree can be cut or not, you have some norms to do that. When you do take these kind of sorry, when you do these kind of surveys, it is very easy for you to understand which trees are you can cut and which trees you cannot really cut. So this is how this is how the purpose of survey is. So whenever you want to do any survey, you need to ask what is the purpose of this survey. You can see this the legend and how the trees are been named. You also need to know the name of the trees. At times they want they as well as botanical name of the tree as well. So all these things you can put in a table, and the table can be referred for all further use. So this is one way of getting this data. H2O. Okay, so whenever a survey is conducted and the drawing is sent to the client, we normally give a table which gives us the coordinates of easting, northing, and elevation. Now, they are specifically the control points, or what you can call it as a station points. Now, why they are required to be mentioned in the drawing or in the table? Suppose I have done a survey for a particular plot, and then the client decides to get the rest of the work done from some other agency. Then for that agency, it should be very easier to understand the control point locations and their values, the coordinates. Then only they can work for the rest of the for the next work. So this is how we normally put it on the drawing, or we at least put it on the table as well. so that they can use these control points for all their further works. So this is again one of the plots. You can see the features are very well. You can see this nala which has been following this line, and again here going into sort of some accumulation of water, and then again going down to that culvert. This is the steep slope area. Again, this is a sort of an what kind of accumulation of water here, small water body like feature. गेला नाही मी बोलत नाही. मी बोलत नव्हतो, ड्रॉइंग ओपन करतोय. Now, as I told you earlier, then this is a survey for a company whose demarcation has been pending for a long time. Now, this happens sometimes that a company or any establishment goes on purchasing land from time to time, and then they have the record in piecemeal, and the record has been not been amalgamated into a single drawing. And so, whatever kind of development they need to make or any expansion they want to make, they have to have a combined and total to get drawing together for the entire plot, even if they have purchased it from time to time. So likewise, we have done this survey for a company, and now whether gila hello. Ah. Now, when we want to check whether these boundaries are correct or not, now this is a village map. This is not exactly the way how we should overlap, but this is again one of the documents which we normally overlap. Now, you can see the yellow line is the line which is there on the ground, and the green one is the demarcation line. Now you can see they are fairly matching. I would always say it is fairly matching because they cannot match 100%. So you can see here they are fairly matching. They are not going off the track. Here again, this is their plot boundary, and it is coming somewhere in here. Again, it is matching here, and this is a land they have purchased which is not there. They have purchased the plot of part of this survey number 33. So there is no definite line here, but the survey number boundary is definite. So this is matching. Again, here also it is matching. So this is essential. This is matching here also. So this is essential to understand whether these people have not gone far off the mark whenever they have purchased a land or whenever they have done any kind of development on that land later on without amalgamation of the entire property. So this is one of the use of the survey and government demarcation. Now this is again a plot somewhere near Bhiwandi area, and it is about 115 acres and divided in two parts on either side of the road. And this is a part of the downstream, and this is the part of the upstream. And there's a river down here. So what we have collected, when we collected any data for the river, what we say the top edge line near the river edge from existing water level, it's about 2 to 2.5 meter high above the existing water level. However, as per the last season's rain, due to water released from the upstream dam, whole plot along the river side was flooded with the released water. Otherwise, water do not rise above this line shown in the drawing, but this is not exactly official line. We are trying to get information from the authorities to determine the exact HFL. So now, whenever we collect any kind of data, even if that data is not final and exact, we still need to mention what that data represents. Why I have read this note, that I understand that this is not the exact HFL, but still what happened last year, as you know, last year the monsoon was very stretched. It has gone almost up to November and December. Then very excessive monsoon happened, and flash floods were there at many places. So this is one of these kind of things happened at this particular plot. So we have mentioned that due to the flash floods, the water was released from the dam, and which was more than usual. So normally, what line we have seen here, shown here, the water in other seasons does not rise above this level. So my plot is well above this level. But now this plot was the purpose of this plot, or the proposed development of this plot, was warehouses. Now, if you want to see, know the if you understand the warehousing, there are huge structures. So it doesn't, there is the thing inside those warehouses as a structural part. Still, those plinths needs to be raised and filled up. Now that cost is a huge cost. So we need to understand the HFL, where exactly the HFL is, and how much area we can utilize, even if there is peak of the monsoon, as we call it in our area, the red line and blue line. The blue line happens to be the highest flood line in 25 years of time, and the red line happens to be the highest flood line happened in the last 100 years. And then there are again monsoon cycles. So for any survey, if the survey site is near the any water body or a river or likewise, you need to have this HFL marked on the drawing, and red line, blue line also marked on the drawing, so that this area or those locations or the area beyond these lines is of no use. So you need to understand that. So whenever a survey is done, you need to understand what that survey, again I emphasize on that point, the purpose of the survey. The purpose of survey, I mean, you don't have to collect the data otherwise, data differently. It's the only thing is that once you understand, you know the why the survey is being done, and while doing it and conducting it, you can put right emphasis on the required points. Now we didn't get this HFL lines or red blue lines last year because that was washed off because of the floods. So now they're again setting up based on the data of the last year. They are again setting up these lines. So at the time of survey, we didn't have that data. So we had to mention a note so that they are aware of it. The client or the people who have been designing, they are aware of it. And once they are aware of it, then they can take things into consideration and put specific conditions or assumptions while making estimates or planning. So the purpose of survey again defines, and you have to mention as much data, you have to interpret as much data which can be helpful when you see the drawing, when you read the drawing. As you read any document, you also need to read the drawing. So when you need to read the drawing, at that time you should be aware of these assumptions or these realities. Now again, this is a drawing of a big society in Pune area. Now this area is almost over 125 acres. This is a very prime location and a prime society, and all the plots are to the tune of say 10,000 square feet and above. Now why the survey was done for this particular area, since it is established and it has been there since years. Now, as the development takes place, not only within your plot but surrounding your plot, then there is some kind of road widening taken place. As you can see here, this road has been widened and the footpath and it has gone inside. The road widening has happened. Again, here the road widening has happened. Now, the society, there were the record of each and every plot, because then this layout was not sanctioned. Though the layout was there, it was not sanctioned, and the plots were allotted in some scheme. So this is in this society, the refugees have been come and they have been set up, and they have taken the plot, and this thing out. I mean, this society has developed. Now, during the course of development, again, at times they have increased their plot in consent with the society, and that area increase or area decrease has not reflected in the society's record. Again, they have some TDR issues, that the FSI issues, that they thought that they have whatever the area they have surrendered to the road, to the corporation authorities, they want to have TDR for that area. Now, when you want to have these kind of purposes, you need to understand the exact area what you are physically holding. So all the survey what we are on the ground, how the things are standing, how the things are there on the ground, and whether they are differing from your records or not. So when we have do that, when we did that survey, this is a very recent survey about a year or two before. Then when we did that survey, at the time of survey, when the drawing was prepared, then only all these things have started. The correction have started. Even the authorities do not have a latest and updated drawing for this entire piece of land, the society. So they are again taking cognizance of the physical survey what we have conducted, and based on that, they are correcting their records. They are checking whether the area which has been accumulated over the period of years, this also has happened in parts, and whether the total of that area is matching with the total of the area they are in possession, and then only they can go for the STDR or FSI what they are looking for. I mean, they want to get the TDR for that particular road winding and so on, and some extra open space if they have left. So, for that purpose, for architect or the liaison person to work for these kind of things, you need to have a very proper and correct survey drawing of the entire piece of land. So this is again one of the purposes which gives you why the survey has been conducted and how these drawings have been put to use in future for all their further works. Now, if you take any of the plot, you can just take out the area by P line and just check with the record and correct that record. And if anything, any of the transaction has to happen, then again, since one of the major advantages of working with procession is that a complete transparency. Now, this is an AutoCAD drawing. I can share it with anybody. That person also can check whether I have done the survey correctly or not. I mean, not me, by any agency. If it happens the other way around, if anybody has done that survey and they have passed on the soft copy of this drawing, I can check that. I can prepare a survey myself, do the survey myself. Not. But this transparency is there, and you cannot really hide things and say that we have just arrived at some conclusion without any backup. So these are the very important backups, very authenticate and authoritative backup, and they can solve many problems regarding the land parcels. I have shown you these drawings. Now, regarding the setting out of the drawing, which we have discussed earlier, I would like to show you how the setting out happens, how we work out the coordinates. Now in this you can see this is the plot layout. Now this plot layout has been prepared based on the government demarcation, and this has been sanctioned from the respective authorities, and now we want to mark it on the ground. Now the stage comes where we mark it on the ground. Now how to mark it on the ground? As I shown you earlier, this drawing has a number of control points which are not there shown on this drawing, but there are number of control points as you have seen the earlier drawing. So you have a network of control points, and now suppose if you want, now this is how we can identify a plot corner point. Say this has been given a number, say 62. Now what is the coordinate of this point? Now we have a command in AutoCAD as ID, as you can see here, ID, that is the identification of that point. When you say ID and click this point, then you can see here, I don't know whether you can show, you can see that, you can see here it shows the coordinates of this point as 1082.2187, 1107.6636, and Z is 0 because this drawing has been converted into a 2D drawing. So 2D means the level Z axis has been put to 0, otherwise you will not get the exact horizontal distance, and the AutoCAD commands also will not work, like intersection, endpoint, and so likewise. So we have made the Z0. So how you can do that? So all the data what you collect from this total station, it is in 3D, that it has X, Y, and Z. So when you download that data, it is in DXF format. What we normally do at that, we save that drawing and we call it a save as, and we put a extension sort of thing as 3D. So that drawing is in 3D.dwg. So once that 3D has been prepared, again we save that drawing, we call it as a save as, and say that is 2D. So the drawing has been differentiated by as a 3D drawing and a 2D drawing. And in this 2D drawing, we change the property of all the points, and in that we make the elevation as 0. Then the drawing becomes a 2D drawing. Then you can measure the distance between any 2 points, and it will give you exactly the horizontal distance. So you can see here the coordinate of this point is the z of this point is 0. So likewise, we take out the IDs of all the points, and then now you have given the numbers. Then what we can do, we prepare a P line. Now I can, as you can see, just let me get this P line. This is the P line. Now then we take the P line from point number 1. This is, we just draft these lines joining the center of these points. And likewise, you can see here all these P line here, the white line. And then when we say Li, that is, if you want to list this, then you can see these are all the coordinates of point. Now they are sequential. So this is 1, 2, 3, 4, and so on. It goes so on. And then you can take these coordinates into AutoCAD, or even you can feed those coordinates into the total station. And at the time of setting out, you can mark each and every point here. And these points, when you mark these points, then a peg is put up out at these points, and that can be replaced by a concrete pillar at a later stage. So this is how. So once these plot points are marked, the roads get automatically demarcated in between roads. So you have roads and plots together. Now this is for a plot layout. As we have discussed earlier, we also have a building layout. When we mark these column centers, footings, and PCCs and everything. Now you can see here, this is a small bungalow. I've taken a small bungalow plot, and this is been superimposed on a survey drawing. So this was the initial survey drawing. This was the initial survey drawing with a block plan. And only the columns marked on this, marked on the superimposed on the drawing. You can see these are the points P1, P2. These are the plot boundary points, as they were also to be marked on ground since the boundary was not there, defined boundary was not there. So we have marked these points as P1, P2, P3, and the plot is defined. Then, as I said you earlier, if you have marked these blocks, you can see the B. The B points means the block. This is a general interpretation. I mean, it does not necessarily have to be the same all the time. Whatever is convenient to you, can just name it. So these are the plot block points. So we have marked these block points. We have also marked this road winding line available from the opposite side of compound wall, and this entire thing has been set out. Once these things have been set out, it has been checked by the architect and the site engineer to get these marginal distances, side margins, front margins, rear margins, and likewise. And then the rest of this marking starts. Now, as you can see here, we have marked at, people sometimes ask to give us a corner point of the columns rather than taking the center point of the center line of the column. So we have given them these 4 corner points, and likewise all the column points are marked. For the PCC, we have marked these corner points. I'll just draw a P line to explain my point. These are the points what we have marked at the time of PCC. Now, when the PCC has been marked, now as I told you earlier, the footing points are to be marked. So, how footing points? How we mark the footing points? I'll just draw this plus line going to the center of the footing, and of course the uh, just a moment, footing as well as. Now you can see the column center and the footing center are same. Now we take a point on the edge of the PCC here. So this is the point what we will mark. This point. So we will mark this point. This point. We will mark this point. We will mark this point at the edge of the PCC, and we will mark this point here. Now, when these 4 points are marked, the circle is expanded because of this end point and all. Once these points are marked, you will put a nail or you will put some oil paint marking on these points, and then the carpenter can fix his footing box. In he already put nails at the center of the box on four sides, so he can just align with a line dori, and he can align the footing with these 2 points as well as these 2 points. Once the footing is aligned, then you can also align the column center, and then this is how it is fixed. And then the footing is cast. So this is how the we work out for setting out on any of the plot. Now I will also show you. This has been shown. Now you can, I will show you, this is the drawing of a garden. This is a very famous garden in our city, Empress Garden, what we call it. Now you can see the details here. Now all these things which are of different and odd shape. Now the legend, what the legend shows, this is the tree bole and the tree code, what we call it, S1, and this is tree bole. This is the root spread over the ground. Now this data is not required many a times. This is being the garden itself and a very old nursery. So they wanted these details as well. So this is tree bole. You can see this is as a tree bole. You can even see the layer. This is what you can say tree foliage, and sorry, the tree spread on the ground, and this is the tree perimeter. That is the foliage on the ground. Okay, this is the foliage. So accordingly, all these details have been collected. You can see. So we have, where we have not shown any foliage, these trees are very small. If you can see, you can just check the properties. The circumference, that is the perimeter, is about 1 feet, and the radius is about 2 inches. So this is how you can distinguish between the trees, say about 4 inch, 2 inch, or say 100 mm or 150 mm, and likewise. So this is how the trees are. We have shown the trees, and you can see the amount of details what we have collected here. So one more inference what we can call, we can derive from this drawing is that the area in between these two. Now, if you see this area, the area between these two is an area open to the sky. This is one of the things which we have derived from the drawing. So again, interpretation of when we read the drawing. So if you want to have make any kind of small structure or any kind of development or a pathway or something like that, you have this much area available which is you can very well utilize without disturbing any of the trees, surrounding trees. So this is how you can plan accordingly. So at places where you can see here, it is very difficult to have any kind of development as the area is thickly vegetated. I mean, the foliages have been covering the entire area. So you cannot have any kind of, you may have some ground clearance, but not necessarily that any development will happen there. Sorry. So this is one of the purposes of this drawing. I will show you one more thing. This I would be elaborating a little bit on the last day when we want to take what you can say a case study or sort of a thing. Sorry, not this drawing. Sorry. One more, uh, one more utilization of the drawing. But I will tell you. Okay. This is drawing of a company in Aurangabad area, Vaduns. This is about 900 acres, the total area. Now, this has been there since 1960s and 70s. So again, they have accumulated the area over a period of time. They go on purchasing the area and develop whatever they require. Now they want to create a new structure in this corner as a vendor park. Now, when they have put up the plans in front of the authorities have told them to give us the up-to-date drawing of their entire premises. So the survey happened. Now, when we have done that survey, along with the survey, they also have a requirement to draw their, as you can see here, domestic line, firefighting line, industrial effluent line, and stormwater line. So they want us to show all these lines on the same drawing. So we have done it on the same drawing actually, but when we want to give it as an output, we have to have a different drawing. This particular drawings give you the area of the road. Now you can see this is the road edge. This is again the road edge. This is also the road edge. So all the area in between. Now these roads are not concrete roads. These are asphalt roads. So if they want to develop the roads, they need to understand what is the area of the road today. So this will give the area of the roads. Then so we call it as a this drawing as a road. Then we go in for the domestic line. So when we see this drawing, it will only show a domestic line. It won't show any other thing. As you can see, this is the domestic line everywhere, and these are the chambers on the drawing. So this is how the line have started and ended, and the main lines, and how they have the direction of the flow also has been mentioned in this drawing. So these are all the data you can see here. This is how the lines have gone inside the toilets. These are the toilets. So this is how the survey can be utilized for different purposes. Now you can see again, if you see the stormwater line, now here you can see this is again the stormwater line network. Again, you can see that in this for the stormwater line, this is the what you can say the rainwater line which is inside the floor shop, and from there they have taken it out. So when these chambers are there, number of chambers we have shown, though they are indicative, the position is indicative, position is correct, the size and these things are indicative. We could not measure the dimension of the pipe actually, so it is just the pipeline what we have mentioned here. You can see how they are collecting the stormwater and going out, and then from there it is going out in here. Now again they also need to show where it goes out. So this goes into the nala. So this part goes into the nala. Here it goes from here in the open trench. Actually you can see this goes here into the open trench, and then again from this trench into the nala. So this nala takes it further on the other side of the road. So this is how the data is there in these drawings. One more drawing. This is okay. Now, what is the difference you are seeing from the other drawings? That when we are working the big land, chunk of land comes, ensure that whatever land has been shown to you, the size of that survey number on the government demarcation of the village map. So normally this is how we put the village map on a. This is the Google image now. This is available in the open source. We have not purchased it or we are not doing anything here. So what we do, we normally do the overlapping of village map onto the Google image. Then we understand the configuration of the survey numbers, what we have been talking about, or you can say what land what land we have considered. We are considering to purchase or considering to develop. So we have the outline, tentative outline of this land, or you have a list of the survey numbers what you're going to purchase. So from this survey number, so when we superimpose, now to superimpose any village map on a Google image, it is some sort of a skill which is required, because then you should be able to find out the similarities between the shapes and sizes on village map and on the Google image, which normally happens as the cultivated fields, or what we call it as वावर, शेतीची जागा. So with those cultivated fields, those shapes are defined for years together. It may vary slightly because they have been doing plowing, maybe increasing the plot a little bit every year, but increase in the plowing. But otherwise, you can see those features. Then the village boundary, which normally we call it as sheep, or the village boundary, normally happens either at the end of the river. That's what you can say. The river is our village boundary, or at the ridge on the top of the hill. So these two lines are normally undisturbed, and based on these two lines and these two profiles, we can fix the Google image. We can fix the village map on the Google image. And once the Google map is once the village map is fixed on the Google image, then you understand the configuration of the entire property and how they are placed. So whatever has, then when you go to site, then you collect some data with the, even with the handy GPS. You come back, then you are told that this is the corner point of say survey number X, this is the corner point of survey number Y, this is the corner point of survey number P, Q, and so on. So you collect that data, you put it on a Google, you identify it with the survey number point, and then you see whether those points are really falling in the same position or not. So, because nowadays you can be very easily taken for granted for not knowing these kind of things, and some false land has been sold to you, is being sold to you. You take that land, but when you go to take the possession of that land, somebody comes up and say this is my land. So this has happened over a period of time. This will happen over in the future also. So we have to take care for these things, and you have to see that from a surveyor you get these things known, whether we are taking the land, what is the land has been shown to us, whether we are taking the same land or not, and whether whatever the land shown is, whether it is, if it is falling outside what has been shown. You are finding it at a different location altogether. This is not happening. You have to ensure that. So these kind of surveys also been conducted. We collect the identification marks in our area. We call them as gurus. That is a pile of what you can say, pile of stones arranged in a circular fashion. So that is gurus, which defines boundary of a survey number. Then there is iron. Iron is a junction of more than one survey number. Now you can see if this is a junction of a survey number say 139, 8 and 14, you will find iron. Now iron is a sort of a stone ledge. So what happens that there is stone ledge of say this much size, say size of about say 4 meter, 5 meter long, and about a meter wide. Now what this information gives us is gives us the information like, it gives us the information like how many survey numbers have taken place, have started from this point. Now you can see here, say I'm not able to click on the line, so I'm clicking a little bit outside the line. So you can say from here, four survey number starts. So you are very much likely to find a ledge of say from somewhere here to here, say about 3 to 4 meters. Here again the same thing, and same thing. And in between you will find a gurus or a center point, which is again a pile of stones arranged in a circular manner. So that means you have found a corner of a junction of say 3 or 4 survey numbers. And likewise, when you superimpose these points on the Google image, now the Google image is already with the what you can say, the global coordinates lat long, and your points also with, when you take them with what you can say, handy GPS or the DGPS, they are again lat long, maybe degree minutes seconds or decimal degrees or likewise. And then when you put them on this drawing, then you come to know that these points are like, okay. So suppose I get a point here exactly, I can very well say that whatever has been shown to me is correct. Now you can see here, these are the pillars. I mean, this is not exactly the iron, what you can say. Let's check with that. Now this is iron. So they, now you can see this iron is close to this point. So there is a possibility that yes, there was definitely an iron here. Again, this iron is showing three lines. So it is like this actually. When you show that, it is like this, one line. So it will follow. It gives you indication the direction of where the survey number actually is starting. So you can see here, this is how the iron will be there on the ground. So again, you can see the similarities between this shape and these points. So it has this particular iron of this particular location. Now over that period of time and the accuracy of the survey maps, this may not match with this. Now suppose if you match, now because this map lapping has been done, again done from whole to part, so they are not just taken care of to only these two irons. We have taken care of the how the survey has been superimposed. So whether this is coming close to the corner points means the survey is going on the right track. So you are not been dumped with some land and you are not been given the false land. So again, this will little bit elaborate on the last day of the when we will take a case study. I will try to bring in more drawings which will explain how the lapping has been done and how we arrived at the corner points of a any particular plot. So nowadays we also say that we can show, we can find your land. You give just a 7/12 extract of your land, and then we can show you your land, the piece of land, where it is, physically there, where it is the position of the physical position of that particular piece of land. Now, if that is encroached or not, it's a different story altogether. But I can show you. Now, I can show you why I'm saying this very confidently is because of this Google and village map and the government record interaction. So with this interaction, you can say, okay, this is the boundary of my plot. You can talk to the people if your plot has been encroached, or you can secure your plot. And then even anybody comes, even the government surveyor comes, you can show him the data, and he will get satisfied, and he will can make it official also. So of course, after checking his record. So this is how actually all these drawings and everything, the survey what we have been conducting, I have shown. This is not what you can say a sort of a I would say lecture, because I wanted to share the drawings and the data, how it is collected and how it is represented on the drawing. Now here also, as I can show you, this is basically the survey of the plot what we have done. This and inside that survey, this is a school building. Now they wanted to again modify the school building, wanted to increase the size of the classrooms, wanted to rearrange the offices and all those things. So this is almost 100-year-old school. So they don't have a record drawings with them. So again we step in and we have prepared these measured drawings. Now this is a drawing measured either with total station or with tape or combination of both. And then we have prepared these floor plans, all the floor plans. Now you can take these floor plans and the areas, and then you can work out very easily based on these drawings. So even the dimensions, the doors, windows. Now, as you can see, this is not an architectural drawing, so you won't see it aesthetically very pleasing, but it is giving you a very correct data. That's for sure. Again, we have mentioned here the window or door opening schedule. Now, normally, whenever we are constructing a new structure, we normally say that the lintel at say 0.9 meter and the seal level is at 0.9 meter or 1 meter, and the lintel at say 2.1 meter or so on. So here also we normally measures each and every window's seal level as well as the lintel level. And this is how the doors are all at the same height, but the windows may not be the same, especially after the construction has been done and they have done some modification in the initial and earlier drawings. So this is how the door window schedule is given. So now this is basement, ground floor, first floor, second, third, second, and then terrace plan. Up to this, we can prepare the drawing. Again, for the terrace plan, you can very well do it with the total station. So whatever time you require to generate a drawing of a terrace plan by taking measurements, it will hardly take the time, even by about 25% of the time only will be required to take the measurement and prepare the drawing, because you are getting the footprint of the drawing there itself, and there is no problem. There is, you don't have to do or take more than one measurement to establish a single line, because then you are taking it with the total station, and then the footprint of that entire structure will, when you download it with the AutoCAD, it will automatically be presented in this AutoCAD software. So these are the few things which we have been working over the years, and the purpose of sharing this drawing was to show you how different drawing have different variety, how drawings have different requirements, and how they are represented on the screen, and likewise. So this is up till now. My presentation and my drawing sharing is over. If you have any questions, then we can start the interaction for this section. I'll just ask the teachers how to go about it. Just a moment.
Any query, any question from the participants? All the participants are requested to type your question in the chat box.
Please drop the question in chat box.
Hello. If there are no questions, I will proceed for vote of thanks. I, S.G. Anturkar, Head of Civil Engineering Department and Coordinator of this FDP, on behalf of our institute, take this opportunity to propose a vote of thanks for this session. At the outset, I thank our today's speaker, Mr. R.M. Deshpande. Sir, we are really enlightened with your knowledge and presence. You shared your practical knowledge, which is very useful for our participants. Thank you, sir. Have a nice day. Thank you very much.
एक query आहे.
Barabar.
Mr. Vaibhav Rajnor, which guidelines should be followed for starting surveying consultancy for institutes? Do you want to start consultancy? I mean, the consultancy is being conducted by the institute. Is that the purpose? Whether you can do this, I mean, these types of consultancy jobs, whether an institute can do or can't do, I'm not very sure about it. But if an institute is there and if they want to have what you can say surveying expertise, one of the way what we have been following in our college where I have studied in Pune in Kushrowade Institute. So they conduct lectures from different walks of the construction industry, and in that they also ensure that a surveying person is there who shares their practical knowledge as we are doing now. So there is no definite guideline for starting a surveying consultancy. And you can just start for any project on a say what you can say a thank you very much basis, and see how you can accommodate yourself in those shoes, and then go onwards. So there is no definite guideline as such for to be followed for starting a consultancy. The second question is Mr. Danish Sayyad. Which application is suitable for quantity calculation from the field data acquired by total station? Now, as you are aware, there are different softwares available in the market. We need to have something which will enable us to check the quantity what has been worked out from our end. What we follow over the period of time, that we prepare a grid, as you know, you have seen in the drawing. Then we number each and every square. Then we prepare an Excel sheet which gives a square number, the four levels of a particular square of that grid, and average of that four level. Then when you take the subsequent levels at different stages of the work, again the grid is prepared and the grid is following exactly the same base as the initial grid. Then again the same pattern has to follow. Then you take this level from for the same square number. So the square number remains same, only the grid number changes, only the level changes. So you again take those four levels, put it in the different same Excel sheet, in different columns, take the average level, then you take the difference of the initial level minus the excavation level and multiply it by the area of the square, that is normally 5 by 5 or 3 by 3, and then you arrive at the quantity. Now when there is not a when the square is not full, and when there is a sloping area, then for that sloping area, you have to take top level and bottom level, average of that top and bottom level, and half the area, as we call it by triangulation. So one half base into height. So the base, the area what you get in the AutoCAD, where the P line is the area, and the height is the difference of top and bottom level. And it has to be multiplied by 0.5 to get the quantity for that area. And this is how you come for you arrive at the excavation quantity. Again, they are asking what are the requirements to obtain a surveyor's license. Is the license valid for only particular municipal corporation or all India? Basically, there is no license required for a private surveyor. There are only two categories, either private surveyor or a government surveyor. If you are not a government surveyor, then you are definitely a private surveyor, and you don't have to have any license requirement for that. And you can work all over India. The only difference between government surveyor and private surveyor is that you are not entitled to sign the document and say this is correct, which will be obligatory for this other people. It may be obligatory for your client, but it may not be obligatory for the other people. So whenever a government surveyor comes and conducts a survey, he gives notice to all the surrounding people. The surrounding people, when the surrounding people comes and in their presence he says that this is the plot boundary, then it is authenticated. As you have continued with the question, what is the authenticity of a private surveyor? Technically 100%, but legally it may not be 100%. But nowadays what happens, then everybody is working with the total station, so at least a system of getting the survey done is at par for everybody. So the survey can be, if your client gets a survey done from you as a private surveyor and he wants to put it to somebody else, then even if it suppose it goes in the court of law, then they can definitely say that you can always cross check whatever has been done by this surveyor. They cannot ignore it altogether. Earlier, they were not taking any cognizance of the private surveyor's drawings. But nowadays, they can at least say, you can at least see what they have done. And if required, then you can correct it. So likewise, it has progressed. But we cannot have a legal authenticity as a private surveyor. Yes, you can definitely authenticate whatever data you have collected. So normally also they ask us to sign the drawings that okay, we have conducted a survey of these drawings, so that why it is signed and stamped that the survey has been conducted by you and your company only, not by anybody else. Otherwise, anybody can generate a nameplates of that sort and take and say this is my drawing and submit it for some other purposes. Thank you very much. Thank you.
Thank you, sir. All the participants are requested to fill up the attendance. Link is available in the chat box.
मी बंद करू का आता?
Okay, sir. केलं हां. And our next session will be start at 3 p.m. So all participants are requested to join at 3 p.m. Thank you.